in this section, no calculators, okay? You need to be able to figure this out without a calculator. And I said this before last week, but there are sections of your quizzes and tests this chapter that you are not allowed to use a calculator for. Like, I will give you 2 separate pieces of paper for a quiz and 2 separate pieces of paper for a test. And when you have, I don't know what color I'm going to do. Say you have the yellow one, and that's the non-calculator section. You may not have a calculator on your desk when you have the yellow paper in front of you, okay? So keep that in mind. Don't just lean on a calculator for these because you will not get to use it for the quiz or the test, okay? Here's what we're doing today. We are going to be turning exponential expressions into log form. Log is just the shortened version, logarithmic form, but I will say log form. Here is how we do logs. This phrase will help you a lot with how you set this up. A logarithm of base b of a positive number x is this. So it'll be a log, and then it's subscript b, a normal x equals y, if and only if b to the y equals x. Okay, so log base b of x equals y if and only if b to the y exponent, b to the y power, is equal to x, which maybe looks like gibberish to you right now. Here's the thing with logs, okay? And I'm just going to write this out so you can go back and refer to it, because people are always like, what the heck is a log? A log is an exponent. That's what it is, okay? It looks weird because it's a word, but it's an exponent. You're finding an exponent. It's kind of like you know how to do this stuff, but now you have to do it in reverse a little bit because of this, okay? The log is the inverse, we've done inverses, right, of an exponential function. Okay, it's the inverse of an exponential function, but really what that means is a log is an exponent. Okay, a log is an exponent. So basically what you're doing is you're trying to figure out what exponent works in some equation. And we're just going to do a whole bunch of these to make it crystal clear how you get there. Here is our first example. We are going to write the exponential equation in its log form. Okay, and you don't necessarily need to rewrite this right now, but I just want you to see what I wrote up top as we do these so we have something to refer back to. So just remember this. When we have log base b of x equal to y, that b to the y is equal to x, okay? So let's say this is our first problem. We would say 25 equals 5 to the second power, right? 25 is 5 squared. If we wanted to write that exponential equation in log form, think about what that's saying. 25 is my x here, and then it's b to the y power, 5 to the second power. So 25 is my x, 5 is my b, 2 is my y. If I'm going to write that in this form, I'm saying log base what? What's the b? Log base 5 of what? 25 is equal to 2. Okay? This is your exponent, right? That is your answer. That's your log. Okay? So we're just taking this and we're reformatting it into the log form, which is that. Okay? How about this one? If I give you 729 equals 3 to the 6th power. Okay, that's going to be log. What's my base? What's my subscript, my little number? The 3, okay? Remember, this is if we're talking powers, that's my base, and the 6 is my exponent, right? So the 3 is my base. Think that little number is my base. It's low, okay? So log base 3 of what? 729. And then the exponent is always the standalone, equals 6. Okay, so I just took the exponential form and turned it into logarithmic form. Does that make sense? Okay, what if we do this? 2/3 to the 3rd power equals 8/27. Okay, in log form, it's going to be log what? What's my base? What's my b? It's 2/3, right? It's whatever the exponent is being taken to this number, right? 2/3 to what power? So log base 2/3 of what? 8/27 is equal to the exponent, 3. Okay, that's your log form. Last one of these. This is just to get you comfortable with it. This is not really to do the math that we're going to do yet. This is just to get you to understand what the pieces are. If I say 1 equals 7 to the 0 power, okay, that would be log, what's your b? B is always the number that has the exponent attached to it, right? So the 7 of what? 1, and then the exponent is always the standalone, equals 0. Okay? Just keep in mind that when you have log form, your answer, your standalone is always, always the exponent. We're trying to find an exponent here. Okay, so here's what you're really going to need to be able to do with this. Example 2. We are going to evaluate logs. Remember, this is no calculator. Okay. Essentially what we're saying here is find the exponent. And here we go. Okay, so let's think about this setup. We're saying log 4 of 16. So log base 4 of 16 equals what? Okay, now here's the question you should be asking yourself. I'll write the question out in words on this first one, and then the rest of them we'll just do it in more of a equation format. You should be asking yourself this question. 4 to what power is 16? Okay, that's the question you're trying to answer on these. Or you could say 4 to the what equals 16. Okay, so this one's pretty simple. It's what? 2. Okay, so your answer is 2. 4 to the 2nd power is 16. You're looking for the exponent, okay? What's this one then? Letter B. If I say log base 3 of 27 equals what? You're asking yourself the question, 3 to what power is going to get you 27? The third power. Okay, 3 to the third is 27. How about this one? If I give you log base 5 of 5, what's your exponent? 1, right? 5 to the first power gives you 5. So your answer here is 1. Okay? How about this one? If we say log base 2 of 16 equals what? You're asking yourself 2 to what power is 16? The fourth power, right? So your answer here would be 4. So far so good? Logs are awesome, right? Super fun. All right, how about this one? Log base 7 of negative 49. Okay? So you're asking yourself the question, 7 to what power is going to give you a negative 49? What? No solution. It does not exist, right? This is one of those DNE problems. If you recall, if we look back up here, right? A log of base b of a positive number x. So when it's a negative number there, it does not exist, okay? You can't do that. So just DNE is fine. Oops. Does not exist. Okay, F. Gonna get a little fancier here. Log of base 5 of 1 over 25. Okay, so basically you're saying 5 to what power equals 1 over 25? Negative 2. Here's the negatives coming into play, right? If you take something to a negative power, you got to move that number to the bottom. Okay, Elijah, put your phone away. So your answer here is going to be a negative 2. 5 to the negative second is 1 over 25. Okay. How about this one? Log base 49 of 7 equals what? Okay, so you're taking 49 to some power equals 7. This one's tricky also. 1/2, right? What is the same as something to the 1/2 power? It's the square root of it, right? So 49 square rooted gets you 7, which is 49 to the 1/2 power, right? This is just like saying we took the square root. 1/2 power. Okay? Hanging in there? All right, how about this one? This one looks different. It's just going to say log 100 equals what? Now here's what you need to know. If there is no base, it's 10. It's base 10, okay? You are automatically doing base 10. Okay, so if they don't put a number in there for you, you're assuming 10. So basically what they're saying here is 10 to what power is 100? The 10th, right? So your answer would be 10. Okay? Sorry, not 10. 2. My bad. It's 2. 10 to the second power. 10 times 10, which is 10 to the second power. All right. Letter I. How about this one? We have 4 more. Log base 6 of 6 squared. What's your answer? It's 2, right? You're saying 6 to what power equals 6 to the second power? It's 2. So they get a little fancy in how they write these sometimes. God bless you. Letter J, we have log of base 3 of 1 over 81. Okay, so what's the question you're asking yourself? 3 to what power gets you 1 over 81? What? -4, right? 3 to the 4th power is 81, so the -4th moves that negative down to a positive 4th power. So 3 to the -4th power gets you there. Are you good on that? Okay, these last 2 are hard. These 2 you got to really think about. But I'm confident that you guys can totally do it because you guys are smart. All right, this one. Log base 9 of 27, okay? So here's the question you're asking yourself. 9 to what power is 27? Now, some of you might be tempted to say 3 because you're like, oh, 9 times 3 is 27. But that's not taking it to the 3rd power, right? That's 9 times 3. Here's what you need to see on these. If you don't see like, okay, wait, 9 to the 2nd power is 81. We're not there. If you don't see it right away, you need to look for perfect squares or perfect cubes in the number that you're working with, in your base, okay? So if you look here, that's a perfect square, right? So if I take 9 to the 1/2 power, what do I get? 3, right? I'm taking the square root of 9, okay? That would be 3. What would I have to do to 3 to get 27? What power? The 3rd power. Okay, so 9 to the 1/2 power gives me 3, which I then would have to take to the 3rd power. So if I'm taking it to the 1/2 and to the 3rd to get there, what 1 power can we take this to? 3/2, right? You're just multiplying these together. And we would say log 9 of 27 would be 3 over 2, right? I'm just taking those 2 and putting them together. We're just multiplying them together, okay? That one's tough, right? Gotta really think about it. How about this one, last one? If I say log base 8 of 16, okay, you're asking yourself the question, 8 to what power is going to get you 16? It's not an easy number, right? It's not 2 or 3. What do you know about the number 8? Is it a perfect square? It's a perfect cube, right? So if this is a perfect cube, we can say 8 to the 1/3 power. What is 8 to the 1/3 power? It would be 2, right? We're basically cube rooting 8. Okay, that's 8 to the 1/3 power. You take the cube root of 8. That's 2, but we're trying to get to 16. So what do we have to do to that 2? 2 to what power? The 4th power gives you 16. So we had to take it to the 1/3 and the 4th power. You go 1/3 times 4 is 4/3. So log 8 of 16 is 4/3. Those are a little more challenging, right? Okay, we won't make you do a ton of those, but you do need to know how to do that. So keep that in mind. If you can't find an easy whole number or negative, look for, can you find the perfect square or the perfect cube that goes with that? and then do something from there to that number. Questions? All right.